I am not super great at remembering to record things. So if I'm ever teaching a lesson and anyone notices that I have not recorded or started recording, please feel free to let me know that. But I am recording now, I believe. I'm pretty sure. This morning, we are going to be learning a little bit about testing and specifically testing with a tool called RSpec. So some of you, I think, have already sort of jumped into this in the project, which is great. And sort of the Turing way, and especially here in this first week, we're like asking you to do things and sort of like backfilling some of the information that you're going to need to really do these things well. So hopefully after this morning, a little bit more of the project is making more sense to you. I am going to try a new thing, which I have not done very often, which is I've got a slide deck on my tablet over here, and I'm going to try using it during this lesson. If it turns into a nightmare, we will switch gears, but I think it's going to be okay. All right, let's go ahead and get started. Oh, okay. Mike can handle the waiting room. All right, so we are going to be talking about testing today, and to sort of get us started thinking about this, I'd like for you all to just take a minute to think about the last few weeks that you've had, like as you get started in the program. How have you known up to now when your program is or is not working? And let's just think about this for about a minute, and then I'll ask some folks to share out. So up to now, how have you known if your program is or is not working? And are there any drawbacks to what you've been doing or how you've been determining that? Great. Oh, Marla, I saw your hand up. If you want to share, we're going to share in just a second. I'm going to give folks just another minute to think. So if you want to share, you can put your hand up and keep it up. But we'll take another 30 seconds just sort of thinking about these questions. All right. Cool. Let's go ahead. I think I saw Marla's hand go up first. So let's go Marla, then Alex, Jacob, and then Taylor. So Marla, go ahead and unmute and share some of your reflection.
Okay. Sorry, I wasn't sure if I was supposed to do
No,
that.
no, it's all good.
Okay, so yeah, I mean, before I did a little bit of mythical creatures, so I kind of did some testing with that. But before mythical creatures, I guess, it was I did a lot of like puts statements to Ruby to see if I was getting to see if I was getting the right values from things. And I was also just relying on whether I was getting any errors from the terminal when it was run through Ruby. So yeah, I guess the drawbacks with that is that it was really difficult to tell what specifically was going wrong sometimes. And there were a lot of like extra, I mean, the put statements I then would like take out later because I don't necessarily want them in there in the first place. So there's a lot of kind of like modifications in that sense too.
Yep, great, I love it. Who did I say was going to go next? Let's go to Alex. Yeah.
I think Jacob was actually next in line. Do you want to go first?
Oh, yeah, if you don't mind. Thank you. I appreciate that. I pretty much did the same thing as Marla. I also do prior and IRB where I would, like if I made like a class, I would pass in arguments, or if I made anything like that. And then it would give me the return value in terminal so that I could see directly that it was holding information. And if I didn't get any errors, if it could hold information, to me, that was like, hey, the code worked. And that was my approach so far.
Cool. I like it. Let's go to Alex and then Taylor.
I would literally just run whatever program I could, and again, look for error messages or do a lot of puts things. And that would turn out to be very time consuming and very, very messy. So I wasted a lot of my own time and probably could have spent more time on like snacks or cleaning the bathroom or like other things that are necessary in life in addition to this.
For sure. Awesome. Thanks, Alex. And then let's go to Taylor.
Yeah, I would agree. At times, it almost seemed like writing the tests was more time consuming than the code itself, and just being off by one little piece of syntax in the assertion, and then basically spinning wheels to figure that out when could have just printed it out and saw that everything was correct to begin with. So that was kind of the issue I ran into, is having a minor error in the test ultimately consuming more time than just printing out what the program is doing and seeing that it was already working correctly in the first place.
Sure. Yeah. So there definitely are some like pros and cons to either approach, both using tests and not using tests. Cool. Let's hear from one more person. I see Antonio's hand is up.
Yeah, I just wanted to add that, because I would definitely put a lot of put statements, but when you have a lot of things going on at once and then you run it, everything is just kind of line after line after line after line. And so to know specifically like what you're doing, I'd often put in spaces to kind of keep track, but yeah, it's just takes a lot of time.
Yeah, takes a lot of time. I think for me, like the biggest piece is this idea of like the time that it takes to manually check if a program is running. And, there are, do I want to go down this rabbit hole yet? No, I don't. So in most cases, when you are building out a program, it is going to be far more time consuming to manually check every method, every class, every like process that could happen. If you have to keep actually executing the code every single time, it might not be as simple as, okay, I'm going to drop into pry or IRB, create this object and call a method on it. Maybe there's something that takes like 20 steps to recreate. And so as you're building it, you're trying to like do those steps, all 20 steps a bunch until you have it working correctly. And that can get very time consuming. And so that is actually where testing really comes into play. So when we think about testing, like, let's just think about what is testing. Do I have a slide for this? Probably not. Oh, there's weird random stuff. Yeah. So let's just talk about like what is testing. Hold on. Sorry. Clearly, I have not used this tool before. So when we refer to testing in programming, what we're really referring to is automated testing. So like testing. Sorry, and my handwriting is very not great, but testing really refers to automated tests. And so this is, when I say automated, what I mean is like I run one command and my whole program is tested. So like I run one command and all those steps that I would need to go through to like recreate a process, all of those things are just kicked off. And at the end of running that command, I get some feedback as to whether or not that thing is working. So when we're talking about testing, from here on out, testing is going to refer to this process of creating automated tests, where instead of like running each method individually and seeing if it works, I am able to run one command and see my whole class or my whole program working or not. Cool. So why do we write tests? We've talked about this a little bit already, but we want to automate the question, is it working? I don't want to have to go through all those steps to determine if it's working. I just want to see, like, I run my tests, is it working? Yes or no? The other piece of like why writing tests is if we have good tests, we can confidently make changes to our code or refactor, make things better, knowing that we have some sort of backstop to say, okay, if I make a certain change and it breaks one of my tests, I know that I've done something wrong. right? Maybe the wrong thing wasn't like directly related to this method that I'm working on, but it somehow broke something else in my program. So it makes it easier for us to be more confident as we make changes, as we make additions to our programs. And the last piece is a little bit harder to sort of wrap your mind around, and we'll continue talking about this throughout the day. But the last piece is like tests give us some starter level of documentation. When a new programmer comes into your program, they should be able to look through your tests and understand like, what does this program do? What classes and methods are in this program and how should they behave? What questions do y'all have so far? And so far I've been talking about testing at a very high level, like as a programming concept, not necessarily directly tied to Ruby or RSpec or any particular language, but just as a concept. This is sort of like what testing is and why we test. Any questions so far? I will take a quick look at the chat. Cool. Yep, snacks are quite important. I would love a mini eclair. All right, great. If there are no questions, I'm going to move on. If you do have questions, please raise your hand. If you've had your hand up for like a while and I haven't called on you, I give you permission to unmute and interrupt me just in case I miss a hand going up. But I will go ahead and move on. And let's talk about writing tests in RSpec. So RSpec is a framework for writing tests. So RSpec is sort of like, well, RSpec is a gem. So let me make sure I've got my notes here. A framework, it's a gem. And a gem is like an extra chunk of code that you can include in your program to give you some additional functionality that someone else has written. So someone else created this RSpec framework and we can include it in our projects and use the methods and classes that are in that RSpec gem. If you have experience with other programming languages, sometimes these little bits of extra code are called libraries or packages. In Ruby, these little like add-ons that we can add to our program are called gems. Ruby, gems, you know, cleverness. All right, so RSpec is a framework for writing tests. It gives us what's called a DSL. Oh geez, oh no, hold on, sorry. I touched the screen in a way that it didn't like. Where am I? Writing tests in RSpec. Yep, this is the one. Okay, I'm gonna get better at using this tool, I promise. Okay, so let's see if I can do this. So a framework, one other word that you'll hear or acronym that you'll hear sometimes when we think about frameworks is DSL, which is domain specific language. Okay, this is like not a need to know, this is just a nice to know, but you'll hear this term thrown around sometimes. So domain specific language, it simply means like, oh gosh, why does it keep doing that? Hold on, sorry. Nope. Okay, hold on. I swear I've used technology before. Okay. DSL, domain specific language. It means we get extra like built in methods. So Ruby out of the box has some built-in methods like toI to turn something into an integer, toS to turn it into a string, length to check the length of an array. RSpec, when we include that gem, we're including some DSL, some domain specific language. That means that we get some extra built-in methods. Cool. There are some, let's see, actually, before I move on, any questions about all those words that I just threw around? Okay, I think the most important thing here is that RSpec is a gem, and it is our framework for writing tests. All right, cool. So how do we actually do this? Stop saying words, Megan, show me some code. So when you are using RSpec in a project, your project is going, oh no, that's, hold on. This is gonna be, let's see if I go back. Let me, nope, that's not gonna work. What if I go back, and then forward again? There we go. Ah, shoot. Okay, hold on. I'm just gonna leave it for now. Sorry, I will make this better next time around. So when you're using RSpec in a project, your project will have a very specific file structure. Every project that you do in mod 1 is gonna have a lib directory and a spec directory. And your spec directory is where all of your tests will live. In your lib directory, you'll have like some class file. So here it's a little hard to see, apologies, but I have like an event class, a food truck class, and an item class. And you'll see in my spec directory, I have corresponding tests for each of those classes. So each class gets its own test. One class, one test file. So here, well, and also I should say, the test files need to be named in a very specific way. We want them to be name of the class _ spec. And this spec piece is like quite important. This is how RSpec recognizes that this is a test file by ending that file with _spec. And of course, these are Ruby files, so .rb. I think I saw someone's hand come up and now I don't see them. Brian.
I was just trying to throw you off. No, so how do you generate that .keep file? I've seen that in a few. How does that get?
Yeah, good question. This .keep file, the short answer is you don't really need it. The long answer is when we, the instructors, set up a repo, if we want a directory to be in that repo, it needs to have a file in it in order for Git to recognize it. And so we just put a file that's just called .keep. There's nothing in there. It lends like no additional functionality. It is simply so that Git will recognize that this is a directory that we want to exist. So you don't need to do anything with it. You can leave it there. You could delete it if you want, but I just leave it there because it doesn't have anything in it. Does that answer your question, Brian?
Yes, thank you.
Okay, great. Cool. I'm glad that I had this on this slide so that you could see that. All right, and this directory structure should feel pretty familiar because we've set up the War and Peace project to follow this convention. Okay, great. The other piece that's important to know is you run your tests from the, oops, this is white pen. You run your tests from the root directory of your project. So if I'm in this, oh, you can't see where I'm like pointing. If I'm in this like my project, I'm going to run my tests in the root project of that directory. So if I pwd, if I see where I am, I should be at the root level of that project, not in my spec directory. Okay. Yeah, Catherine.
Yeah, so going from mini test to RSpec, I took a lot of my files and like I did RSpec -- init, and then it created the spec helper and the RSpec one.
Yeah, you should actually not
Or-
need to do RSpec -- init. I'm going to talk about how we actually build the RSpec file or the RSpec tests, and you shouldn't need to do that.
Okay.
But if you did and it created some extra files, just leave those files alone.
Okay.
Yeah. And what Catherine is referring to, we just switched to teaching RSpec in Mod 1 like last inning. Before that, we taught a different testing framework called mini test. So that's from some legacy, from some legacy lessons. Marla.
Yeah, I guess this is kind of a similar question, but so from the root level, what I've been kind of working through War and Peace as much as I can so far. And even when I was doing mythical creatures, I wasn't able to get the tests to run unless I was in the spec directory, not in the root directory. So I mean, I'm assuming maybe we're gonna talk about that, but I guess that's
yeah. So when a test like doesn't run, if you okay, let me restart that sentence. If you have an issue where a test doesn't run and then you switch directories and all of a sudden the tests run, that is related to how the tests are looking for specific class files. And I'm going to talk about that in just a second. But for your projects, you will run your tests from the root directory. So like in War and Peace, it should run from the root directory if your tests are set up appropriately.
okay.
So there's a piece of the test itself that could be causing that issue.
Okay, but I guess the structure, it's just the way that it's looking for the files. It's not like
Yes.
the creation of the test in general.
Correct.
Okay.
Correct. Yeah. All right. Any other questions so far? Oh, and I see that Brian has a question in the chat. Brian, do you just want to ask that aloud for the group?
I mean, yeah, it's just, I didn't know if there was a difference between the bundle execute RSpec and then the file name, or just RSpec file name. Early on, I couldn't get something to run, and I was using Taylor to put this in the Slack channel, and I was able to run tests with the bundle execute, or like I assume that's what it stands for, but yeah, I didn't know if there's a.
There is a difference, and I'm not going to go too deep into it, but it's essentially if someone has written a test suite in a different Ruby version than yours, you might need to bundle exec RSpec for reasons that would be interesting for you to research, but I'm not going to go into right now. So yeah, if someone else created the repo or the project, it's possible that you will need to bundle exec RSpec. But in your projects that you're creating, you should not need to do that. The other piece, which is why I'm glad you asked this question, is there are a lot of different ways that you can sort of like start your tests running. The most simple and straightforward way, I think, is simply using the command RSpec. So you'll see here, like in this little snippet, I don't have a file name here. I'm just running all the tests in my project. So if you simply type RSpec, it's going to go look for any spec file and run those tests. Now you could run RSpec and then a specific spec file if you want to like hyper focus into one test. But my default generally is to just like type in RSpec, run it, and then if I want to run a smaller subset after that, I might do that later. Great questions. All right. Okay, let's see. It is 9:24. What is my next slide? Yeah, so in the next slide, we're going to actually do some coding. So I think let's take a POM now. I think this will make the most sense. So let's take a POM now and we'll come back at 9:30. So come back at 9:30. All right, it is 9:30, so I'm going to go ahead and get started again. I have restarted the recording. So we're going to do a little code along. So I'm going to have you all writing code right alongside me. And what we're going to do is we're going to use this interaction pattern. Wow, I am really good at this, y'all. Okay, here we go. Try this again. We're going to use this interaction pattern, interaction pattern, to help model our tests. And an interaction pattern is really just some representation of what our project or what our class should be able to do. And so in this interaction pattern, we're modeling like the behavior of, wow, why does it keep doing that? I swear I practiced this and it did not do that when I was practicing. Okay, hold on. Go back to this. Okay, here we go. So we're going to be modeling the behavior of this student class. And when I am writing tests, or when like we all are writing tests, what we're shooting for is to have one test per method. So one test per method. Oh no, I'm running out of space. There we go. One test per method. So I'd love to hear from you all. How many methods, AKA tests, do you think we're going to have? And let's take like 10 seconds, 15 seconds maybe to look through this. And let's see if we can decide like how many methods do you think we need to test here? Another second. How many methods are there? And let me get a show of physical fingers. How many methods are we going to need to test? How many methods are there? Cool. I'm seeing a few fingers. I like it. I've got some good variety. So I'm seeing some 3s, some 4s, some 5s. Let's go ahead and count them out. So as I'm looking through here, the first method that I see is, so I'm going to use a different color here. The first method I see is this new method. This is a method that is called on the student. So it is a method that we need to test. We need to test this idea of a new student being created. Then as I read through this interaction pattern, the next method is name. And then I've got a method for cookies. And then I've got a method for add cookie. And then I see add cookie again. I've already identified that as one of the methods that I'm testing. So it's not a new method, or it's not an additional method. It's just I'm using that method again. And then I see student.cookies again. And I've already identified cookies as a method. So I don't need to mark it again. So as I went through and marked all these, I'm basically like underlining all of the tests that I need to create. So I need to create a test that that new method is working, a test for its name, a test for cookies, and a test for add cookies. Now the interaction pattern, of course, calls more than 4 methods. It calls add cookie twice, and it calls cookies again after add cookie. Sometimes we use the same method that we've already maybe like used before or tested before to confirm some additional functionality. So when you're looking at an interaction pattern, the important bits are each first time that you see a method. So each method deserves one test. Regardless of how many times it's called in the interaction pattern, we want to start with one test per method. We might add additional tests for specific methods if they have like a lot going on. But the base level, like where I want y'all to start, is one test per method. All right, cool. So let's jump in. I am going to leave, I'm going to leave this silly iPad behind. So I'm going to stop share for a second. And I am going to drop that image that I just had into your 2105 code help channel in the testing lesson thread. There we go. So let me share my screen. Get this chat out of my way. Share my screen. We'll go to desktop 2. Bring all your lovely faces down here. Cool. So I just put that interaction pattern that we're going to be working on in the code help testing lesson thread if you need it. But we are going to start with a little code along. So I'm going to go to my terminal. And where did it go? It's hiding from me. Oh, it's behind all your lovely faces. Isn't Zoom fun sometimes? All right, great. So let's go ahead. I'm going to make this a little bit bigger. Come on. Why is it not letting me make it bigger? Ah, my terminal is frozen. Let me just quit this and we'll just restart it. Silly terminal. All right, there we go. Now it's working. Make this nice and big for us. And I'll just make this full screen for now. How's this text size? Is this okay? Okay, great. So what I'm going to do is I'm going to go into, I've got a Turing 2105 mod 1 directory, and I'm going to start a project. And I think it would be beneficial for you all if you are coding along. I will leave that up to you ultimately, but if you want to code along, I'll be trying to go like at a followable pace. So in my terminal, I'm going to make a directory for a project, and I'm just going to call this like my first tests, maybe. I don't know. You can call your project whatever you want, but that's what I'm going to call it. And then I'm going to cd into that project. And thinking back to what we talked about when we were first discussing RSpec, I need 2 directories in here. Does someone want to shout out what are the 2 directories that I need?
Lib and spec.
Lib and spec, great. So I'm going to go ahead and make some directories, and I need a lib directory and a spec directory. Okay, and so now if I ls, I should be able to see lib and spec. So that so far so good. And what I'm going to do, since we are working with a student, I'm going to go ahead and create my student class file and my student spec file. So I'm going to touch lib student.rb and spec student underscore spec.rb. Okay, so now I should be able to open this up in Atom. And pull my Atom window onto the right screen. And now I see I've got a lib directory, a spec directory with some empty files in each. So let me go ahead. I want to reformat my screen just a little bit, because this is generally how I like things. Make this a little bit bigger. There we go. All right, sweet. So what I'm going to do is I'm actually going to start by writing a test first. We'll talk a little bit more about this in a second, but the way that we are going to teach y'all to program here at Turing is with tests first. So we start by writing a test, and then we are going to use the test to help us write the code that will make that test pass. So I am going to, at the very top of my spec file, the first thing I need to do is require RSpec. And this actually like tells my program to include the gem RSpec. So I need to require RSpec. And then what I need to do is I need to tell this spec file where the test, or excuse me, where the class that I'm trying to test is located. Okay, I need to tell this file where the class that I'm trying to test is located. And so I'm going to require dot slash lib slash student. So I need to tell the test where the class file is located. And this is where, depending on how you set up this line, it might change where you need to run your tests from. So this require statement is going to look for files based on where you are in your terminal, where you're running this code from in your terminal. So if I am at my root directory, which is where I should be, it's going to look for a lib directory. And then inside that lib directory, it's going to look for the student file. Yeah, Marla.
On some of the files, I saw require underscore relative. Is that similar? What's the difference, I guess, between those?
Yeah, the difference between require and require relative is require will tell your program to look for files based on where you are in your terminal. So like from here. Require relative will tell your program to look for files based on where this student spec file lives. So like from here. Okay, I don't want to go too far down that rabbit hole, so I'm going to leave that there. The most conventional way to do it is to require your files so that when you run your test from the root directory of your project, everything works or all the files are hooked up appropriately. So this is the most conventional. This is the way that we're going to have you do it for your projects. Okay, I've said the word conventional a lot. Just to be clear, there are some things that we do that are hard and fast rules, like Ruby will break if we do it differently. And then there are some things that we do because Ruby is a community of humans. And as a community, we have decided to do things in a certain way just to make things easier for other folks jumping into new projects. And this idea of like how we look for the files is a convention, not a rule. It's not something that will break Ruby if we do it differently, but it's a very strong convention. And I would say Ruby as a programming community has some of the strongest conventions in programming. When you get into later mods and you get into like JavaScript, it's going to feel like the Wild West with no rules, no regulations. Ruby has a lot of rules and regulations. Cool. I think I saw another hand come up briefly. Was there another question? Yeah, Brian.
Yeah, sorry, it was me again. So you said you didn't want to go down that rabbit hole, so I decided against it. I was just wondering if you do the require relative, does that change how you would do that? And that's that file path there. You'd have to do 2 dots to go back up to then hit the library. Is that?
It will change.
It was terrible.
Yeah, it will change the way that you need to set this up. If you have, I would say put that question maybe if you want to discuss it further into the lesson thread, and I can add some more color there. All right, cool. So now that I have required RSpec the gem, I've told this test where the class is going to live. Now I can actually start my test. So the way that this looks, I'm going to write some of this out and then I'll talk through it a little bit. I'm going to describe student. Okay, so this code should look a little semi-familiar, but probably like pretty uncomfortable. So describe is a method that we are getting from RSpec. So describe is part of that domain specific language, that DSL that we're getting from RSpec. So describe comes from RSpec. Describe, how do I want to say this? So describe will then take an argument that will be like some sort of description of the thing that we are trying to test. So in this case, we are testing the class student. So I'm going to describe like, hey, we are testing this class, capital S student. And then the do and end is basically like the box that all of our student tests are going to live in. We'll talk more about do and end blocks throughout the week. But for now, it's less important to know like exactly what is happening here and more important to know the pattern of what is happening here. So we describe the class name, put a do, and then close that do with an end. Okay. Okay, so thinking about the actual, so this is all like sort of setting up the test, getting ready to write our first test. Thinking about the actual test that we're going to need to write. If I look at this image again here, we said the first method that we come to is new. So I need to know that a student can be created by calling new on it. And in this case, specifically, we're going to call new with this argument of Penelope, and that should create an instance of a student. So I'm going to go back to my test here, and I'm going to say it can be created. Okay. And I'm going to keep writing this test, and then we'll talk about the structure of it a little bit. So I'm going to need a student. So my student is going to be student.new, and we're sending the string Penelope. And then I want to verify that that student can't type. Okay. So let me walk through this real quick, and then Catherine, I will get to you in just a second. So inside my describe, which holds all my tests, I'm going to write a single test. So from line 5 to line 9, this is a single test. We start each test with it, and then we tell, or we like give it some description of what we're testing. So it can be created. I'm just making up these names. We want the name of our test to be like descriptive, but not overly long. So it can be created, or it exists, or it can call new, something like that. Doesn't really matter too much what we name these. Find some way that feels comfy for you, and that'll be like your style of programming. This is the way I'm doing it now, so this is like my style. Inside of our test, we need to create, or we need to like have something in there to test. So I'm creating this student, and then I'm expecting, after I create the student, I'm expecting that that student is now a type of student object. So I expect the student to be a, and then the class that it is. So this is there's a lot of RSpec domain specific language here. So expect is a method that we get from RSpec. .to is a method that we get from RSpec. Be a is a method that we get from RSpec. Okay, again, not super important to know exactly 100% everything that's going on under the hood. More important to know this pattern. We need to verify that a student or any type of class can be created. Catherine.
So I think I got confused when I was going over it myself. So I noticed that in some of the other things I was going over, that there was like describe student do, and then there was another describe, like
we'll talk about that.
Initialize do.
Yep, we'll talk about that in just a second. Yep, good question though. Okay, cool. So I've got one test. Let's go ahead and run it. So I'm going to go back to my terminal. And like I said earlier, there's lots of different ways that you can run these tests. I like to simply run all the tests that I have at any given moment. So I'm going to type in RSpec and run this and move my Zoom prompts out of the way. And I get an error, which makes sense because I haven't written any implementation code yet. So I'm going to scroll up a little bit. Actually, I'm going to make this just a little bit bigger. So it says an error occurred while loading. It like gives me a lot of text about where that error occurred. And then it says, and this is kind of the most important part here, is it says we have an uninitialized constant student. So my test doesn't know what a student is. And this is specifically coming from line 4 in our test. So it got only to this line and excuse me, my test was like, I don't know what capital S student is. Whoops. Blake, did you have a question?
Yeah, so when I ran mine, I just get command not found RSpec.
Oh. Yeah, and you're having some gem install issues, aren't you? Yeah, shoot. Yeah, you actually, yeah, if you're getting command not found, you'll need to gem install RSpec. And if you are one of the lucky few who is having some issues with that, we're gonna meet together again over lunch. So if you're still having issues with that, send me a DM in Slack and we will have another lunchtime debugging session. Sorry, Blake, and anyone else who is also having that issue. All right, cool. So we've got this error. Oh, I'm gonna kill this gem install. So our test doesn't know what a student is because we haven't created that class. So I'm gonna go to my student class file and I'm gonna pull this up over here. And I need to actually start creating my student. So I'm gonna say class student. And now my test should know what a student is. That's not what I want to do. Let's go ahead and just run this. Okay, so I got past line 4 and I know that because now my new error is coming from line 6. So if I look at line 6, okay, cool. Something's going wrong on this line. What's going wrong? I am trying to call new, which calls initialize, and I'm trying to give it 1 argument, but my class is expecting 0 arguments. So I actually need to tell my student that, hey, when you get initialized, when you get created, you're gonna take in 1 argument. So I'm gonna say def initialize, and this argument looks like a name. And I'm gonna run this again. Okay, cool. So I have 1 test and 1 method that is working. 1 test that is passing, 1 method that is working. All right. Let's go to our interaction pattern. So now I'm done with this. Now I want to make sure that I can call student.name, and that should give me Penelope. So let's write a test for that. I'm going to create a new test, and I'm going to say it. I'm just going to say it has a name. And again, I'm going to need a student to be able to verify that that student has a name. And I'm going to this time expect that the student name, my participants tab is in the way, should be equal to, oh geez, that's not what I want. Should be equal to Penelope. Okay, so now I have a slightly different expectation line. Now I'm expecting student name to equal Penelope. I want to make sure that when I call student name, whatever that gives me is equal Penelope. Okay. Questions so far? All right. Oh, Corinna.
So is that just testing that we've included a name in it for the name?
This is testing that if I call the method name on
Mhm.
a student, this student specifically, if I call this method on the student, it's going to give me this string Penelope. Yeah.
Okay.
Yep. Michael.
Yeah, I had a question about the space. So in between student and expect in each of the tests, you're adding that space in there. Is that typical convention or like, is that how we want to set it up?
Yeah, I would say it is typical convention. And I'm going to talk a little bit more about like maybe why that's a convention a little bit later.
Okay.
Yeah,
Thank you.
good question. Yep. All right. And then Corinna and Michael, if you don't have other questions, I'll have you just lower your hand. Awesome. All righty. So I've got my test. Let's go ahead and run it. And I have an error. It says no method error, undefined method name for the student. And that makes sense. I don't have any method name set up in my student class. So I'm going to go ahead and set that up. And I'm going to follow the pattern that I believe Ian talked about yesterday, which is when I send in this information that I want to be able to just recall from the student, like I'm sending in a name attribute, I want to recall it. I'm going to set up an instance variable and set that equal to the name that I'm sending in, and then create an attr reader, an attribute reading method for my instance variable name. Okay, so now I'm going to go ahead and run this again. And now that test is passing. I have 2 examples, 0 failures. Questions so far? Let's go Caroline and then Alex and then Jess.
For some reason, I'm getting 2 examples and 2 failures. Is that, not sure where I'm going wrong here.
I'm going to stop share and I'm going to have you share your screen and we'll see what's going on.
Okay. Can you see this?
I can. Let's see. Oh, this is a very fun error. You have actually misspelled initialize, and so it doesn't recognize that method. Yeah, this will happen. This will not be the only time this happens.
Okay, thank you.
Yeah, go ahead and run them though, and just make sure that that fixed it.
Okay, yeah, now I have 2 examples and 0 failures.
Excellent.
Thank you.
No worries. All right, let's go Alex and then Jess.
Hey, I am getting 0 examples and 0 failures. So
Okay.
I'm guessing I'm running it from the wrong spot.
Let's
Did I
see, why don't
share?
you, yeah, let's go ahead and share your screen. All right, cool. And will you, let's see, testing.
And I think I know where it's coming from. Like I've
Okay.
got this, I typed it out already. So from the example that you gave us, it's within the same file. This is the code along that we're doing. And this is also the code along.
Yeah, so in order for RSpec to recognize a test file, it needs to be named _spec at the end. So in your lib directory, I would expect a student.rb. And then in your spec directory, that file needs to be named student_spec.rb.
Ah, all right, thank you.
Yeah, these are all great
Anyone got a
questions.
quick how to rename that real quick?
Oh yeah, if you use 2 fingers to like double click, or not double click, but 2-finger click on that. Yep, right there. And then go down to rename. And then just give it whatever name you want. And then it's important that you hit enter, or sorry, return. So _spec. Yep, and then hit return to make that happen. or enter or return. I don't know. Keyboards are silly. It already exists. So go ahead and just click out of that and open up your spec directory for me. So like draw on the left-hand side. Okay, cool. So I think, can you open that student_spec file? Yeah, so I think you probably just need to copy what's in that student.rb file into the student spec.
Thank you so much.
Yep, no worries. All right, cool. And then Jess.
That was the same thing with me.
Oh, great. Excellent. All right, cool. So what I think I would like to have y'all do, let's see, it's 10 o'clock. Let's take another palm. We're going to take a palm and we will come back at 10:05. So come back at 10:05. Oh, Ted, did you have a question?
Yeah, I can't get any of that to run. It says the gem's installed, but it keeps saying I put an RSpec into terminal and then click run. It just says command not found RSpec.
Yeah, so you probably don't have the gem installed either correctly or at all.
I checked it. I don't know. All right. Well, I'll see you at lunch.
Okay, perfect. Start the recording again. Okay, so the next thing that I want to do is I want to let you all try this on your own just a little bit. So I'm going to send y'all into some breakout rooms, and I would like for you and your partner in the breakout room to see if you can write the test for this cookies method. So this is the next method that we're going to test. I want to see if you and your partner can write the test for this method. I'm going to look through and see. I know that Ted, Blake, and Christina are having issues. I think that you all are with folks that are able to write code. Yeah, Miriam?
I'm also having issues with the RSpec.
Okay, great. Definitely DM me so that we can get you in that lunch session. Cool. Let me just see. Okay, cool. So what I'd like for y'all in your breakout rooms to do is see if you can write this test for the cookies method. If you are, let's see, how should we do this? If you've been coding along, that's great. You can actually write it like in your code files. If you have not been, you can like write it up in any format. I just want to see I just want to give you all some time to practice this. So I'm going to send you off into breakout rooms for 10 minutes, and then we'll come back and I will walk through it together. Questions about what we are about to do? Yeah, Michael.
Where was that the prompt at, or the exercise?
Yeah, great question. It is in your 2105 code help channel. I have a testing lesson thread, and I threaded an image to that in the code help channel. Cool.
Thank you.
Let me set these up so that they auto close. Yep, 60. Okay. Any other questions about what I'm asking y'all to do in your breakout rooms? If you need assistance, I think if you raise your hand, it will alert me that you need help. And I will see y'all back here in 10 minutes. Okay, great. So we're back from our breakout rooms. one thing that I'll say is in breakout rooms, I think that there can often be some like very interesting discussions, questions, inspiration that comes out of those. We won't always get to share like everything that we talked about in those rooms, but I would encourage y'all, like if something really cool came up in your breakout room, like post it in the Code Help channel. Just like, hey, here's a thing that we discovered or learned or we're curious about that other folks might benefit from. I think that that can lead to a lot of really good conversation. Okay, I will get off my soapbox now. So as you all were in your breakout rooms building this test, I also built this test. And so you might have something like slightly different from me, which is okay. Probably the biggest difference is going to be like what we all put in this string here. So it doesn't really matter too much what you put in here, as long as it's sort of descriptive of what the method should do. So I said that it should start with no cookies. So a student starts with no cookies. And sort of the reason that I made that determination was if I look at our interaction pattern here, the first time I call cookies, it's empty. And then I do some stuff and then I call cookies again, and now cookies has some stuff in it. So I want to capture the idea that a student starts with empty cookies, with no cookies. So that's why I did that. Doesn't make it the one right way. It just makes it the way that I did it. And then in my test, I need a student to confirm that that student starts with no cookies. And then I'm going to use a very similar expectation to what I have above to say I expect the student.cookies to equal an empty array. Any questions about what I've done here? Yeah, Caroline.
We were talking about this in the breakout room, but so to be and to equal, will those be the two main, I guess, terms that we'll use there?
Yeah. So I would say for 98% of your tests, you're going to use to be a or to equal. And to be a, this is a very specific, well, they're all specific expectations, but what this is saying is I want to confirm that student is a type that like my variable student is a type or is an instance of the student class. Sorry, this is really long. But this to be a means I want to confirm that this thing that I'm sending into my expect is an instance of this class. So if I said instead of student, if I said string, I would be expecting student to be an instance of a string. But in this case, I want to expect that it's an instance of a student. On this line down here, what this is saying is I want to confirm that student.name equals Penelope. I want this to give me true. So those are the differences.
Okay. And what would the term be for those little bits of code there? Like if I needed to Google it for some reason, instead of just coding or typing in to be a or to equal, if I wanted to look at other ones like in the future.
Yeah, so these are, I was actually going to, and I'll just drop it now since we're talking about it. There are other expectations that you can use, and I'll just link those docs here in that same thread. But they are, so this is the link that I just threw in there. So there's things like I can expect something not to equal, or I can expect something to be truthy or be true, or What are some other like useful ones? A lot of these you won't use that often, but like to include, that might be very useful at some point. So yeah, there are a lot of different expectations, but I would say 90% of, probably 95% of what you're going to do is going to be with either to equal or to be a.
Awesome, thank you.
Let's go to Lee and then Antonio.
This is just a clarifying question, I think, based on where we got hung up. But so each time you do one of these individual tests, you have to reinitialize the class then, correct?
Yes.
In this case, Penelope, you can't just like jump to testing the cookie method. You're gonna have to create the class then, okay.
Yeah, so whenever you see things like do and end or def and end, you're sort of creating little boxes in your code. And we'll talk more about this in the scope lesson later, but you're creating these little boxes where anything you do in that box needs to be available to you in that box. And so, yeah, you need to recreate that student at each. You need to create the student so that you have access to it. Great, Antonio.
Yeah, so is it possible that you created a test that ultimately passes but isn't actually testing what you intend? I mean, I imagine you really have to like be kind of, I don't know if you have to be intentional about doing that, or if that just happens and you have to be like, nope, you got to go back and rewrite that test because that's not what you actually meant to do.
Yeah, it's definitely possible that you will write a test that isn't quite testing exactly what you want. And that is why, well, that's one of the big reasons why we test with other people, right? We need like another set of eyes just to make sure we're doing the thing that we want to do. I will say that in mod 1, most of the things that we're going to test, it's going to be like pretty clear. If you're writing a test that is not actually testing what you want, pretty clear. I don't know. This will become more of a problem as you go further into your programming career, I guess is what I will say. But you might have something like what if instead of expecting cookies to be nil, what if I say I expect this empty array to equal this empty array? Is this valid RSpec code? Sure. Like there's nothing about this that RSpec is going to freak out about. But is this actually like testing anything? Not really. It's like testing that Ruby is doing what it should be doing, but we should be able to trust that Ruby is working. Cool. Jacob.
So sorry if this was clarified earlier, but when it comes to like the it, student, expect, end block, is it like other methods where if you have, like, let's say I had underneath the expect student cookies to equal whatever, let's say I had another line of code that was expect and a new parameter. If I were to run that, would it only run the last line, like that last expect, or would it run both of them?
It will run both of them. So if I have like 2 expects in here, or let's say like expects hello to equal hello, it will run both of these. So you can have as many expects in your it block as you want.
Okay, so if it does pass, then it's not just because it's just running the last one that passes everything that it ran past.
Yes.
Okay.
Yep.
Awesome.
Yeah, so in this case, this will actually fail on line 20. And so it won't ever run this expectation until line 20 is working, and then it will continue running expectations. Now, I would say that if you have a test with like 30 expectations in it, probably like either way overkill on the expectations, or you're trying to test too many things in one go. Cool. Let's go Blake and then Matt.
So it could just be a very simple thing. I'm just like reading it wrong, but having the student equals student.new Penelope makes sense because student is Penelope, right? So then when we go down to student with no cookies, it looks like it's almost like the student is cookies. It's kind of how I'm reading that. When we do student equals student.new Penelope expect student.cookies.
Yeah, so we're
I guess
expecting
why
when
wouldn't
we-
it be like cookies equal?
Yeah.
I guess is my question.
So if it were simply cookies, Ruby would expect somewhere in this it block to have a variable or method called cookies. And we are trying to test the method cookies, but in order to call a method, we need to call it on something. Like we need to run this method on a thing. And the thing that we're running it on is the student. We are calling the method cookies on the student object. So we're saying like, hey, student, go do the thing that you're supposed to do when I call this method on you.
I guess I was looking at the student just above that, like the like student, the red one. So like in that same it, so that one right there. Why? I guess that being called student, and in our group, I had said, oh, that should probably be cookies because we're talking about cookies now. It's like,
yeah. So the reason I'm calling it student is because I am creating an instance of the student object and setting that to this variable. So I mean, I could call it whatever I want. I could call it zebra. It doesn't really matter to Ruby, but it's holding on to this instance of a student object. And so for me, it makes the most sense to call it student. And now this instance of a student object should respond to the method cookies. So I should be able to call the method cookies on that student object. And that is what should give me this empty array.
Okay.
Cool. Let's go Matt and then Antonio.
Hi. So I realize that it's very likely just approximate, but could you reiterate the rough percentage that we're going to use BA and EQ?
Sure. 93.8724.
90+% is what I'm going to write down in red here.
Yes, 90+%. And I would say of that 90+%, 99% of that will be 2 equal. How's that for a lot of numbers? Most of the time, you're going to use BIA or equal, and most of the time, it's going to be 2 equal. But I will say every test file, every spec file will have at least one be a student, like be a class. We want to make sure that when we create that class, it is actually created. When we call new on that class, it is actually created. Then most of the rest of your tests will be 2 equal. Antonio.
Yeah, so I think piggybacking off of Jacob, when you add like another expect code line in there, does that mean you could potentially combine like has a name and starts with no cookies and have those 2 lines and it like runs that at the same time, even though you wouldn't really want to do it that way, but you theoretically you could?
Yeah, you could. You could. I think that's all I'm going to say about that for the moment. All right, great. Okay, let's go ahead. I've written this test. I'm going to run it and actually like create the code to make this pass. So I'm going to go back to my terminal and run my test. And yep, undefined method cookies because our student does not have a method cookies. Now, this idea of a student starting with no cookies, and if I look at my interaction pattern, oops, that's not what I wanted. Slack, there we go. When I look at my interaction pattern, when I create this new student, I see this sort of like hashtag, angle bracket, capital S student. This is indicating that this is going to return an instance of the student object. And this student looks like it should have an instance variable for cookies and an instance variable for name. And so that is a clue for me that not only is my class going to have this name instance variable, but also it's going to have a cookies instance variable. And based on my test, that's going to start as an empty array. So I'm going to say at cookies equals empty array. And to actually be able to call dot cookies, I need some method to give me the value of this instance variable. And that method is going to be an adder reader for cookies. Ian probably covered this, but just to like reiterate, because this I think is an important point, these adder readers, under the hood, you're getting a method that looks like this. Name, at name. So under the hood, Ruby is creating a method that simply returns the value of the instance variable that matches the name of the adder reader. So if I had an adder reader for age, maybe that makes sense. I would, under the hood, Ruby's creating a method age that is giving me the value of the instance variable age. Okay, so this is what's happening under the hood when you create these adder readers. Okay, bit of a side note, but I think an important thing to keep in mind. All right, cool. So got my adder reader, I've got my instance variable. Now this should be passing. Okay, great. Excellent. So we've got that. Let's see, it's 10:35. Let's take a palm. When we come back, we will finish up the last test, talk a little bit more about testing as a concept, and then I will let you go on to Mike. So let's take 5 minutes. Let's take till 10:40. 10:40. Sorry, slightly shorter break. 10:40. All right, it's 10:40. I have resumed the recording, and we're going to write this last test for our student class. I'm going to go back to our interaction pattern, and the next method that we need to test is that a student can add a cookie. Now, one thing that you'll see here in this interaction pattern is, unlike all of the method calls above, this add cookie does not have a return value listed out here. Now, that doesn't mean that add cookie doesn't have a return value, because every method has a return value. What it really means is, I don't really care, or my program shouldn't really care what this method returns. What I should care about is that after I call this method twice, now when I call cookies, I see those 2 cookies in my cookies array. So this is, we sort of have like 2 different types of methods here. We have some methods that just ask an object for information. So name and cookies, we're just asking an object for information. And we've got a couple methods that tell an object to do something, like, hey, object, go make a change in your universe. And this add cookie and new really also are those like changing methods. So when I call this add cookie, I'm not asking for information. I am telling my student to change something about itself. Hey, student, add this cookie to your array of cookies. So there's a slight difference in these 2 types of methods and how we're going to test them. You'll sometimes hear these 2 types referred to as command and query methods. So a query method is simply asking for information. A command method tells an object to change in some way, like change yourself, add this cookie to your list of cookies. Cool. So command and query methods. All right, let's go ahead and write this test. So I need, let's see, it can add cookies, let's say. So again, I'm going to need a student. And then I need to actually like ask that student to add a cookie. And I'm going to add, I like peanut butter cookies. Let's add cookie peanut butter. Oops. And let's go ahead and add cookie. I really love those cookies with like all the things in them. I think they're called monster cookies. Monster. Can we just call it monster? Peanut butter cookie, monster cookie. I don't know. Anyway, those are going to be the 2 cookies that I'm going to add to this student. And so after I call this method, now I can expect that my student cookies is equal to the array peanut butter cookie and monster cookie. So I am testing this add cookie method, and I'm using my query method cookies that I already tested above to verify that add cookie is working. So sometimes your expectation doesn't include the exact method that you're testing. Sometimes your expectation is going to be made on some other method that will help you confirm that the method that you are testing is working appropriately. And again, a hint to me as the coder that I want to do something like this is in that interaction pattern, I'm not seeing a return value for add cookie. So whoever wants this program built doesn't care what the return value of add cookie is. What they care is that after I've called this method and sent these 2 cookies in, I can see that my student has those 2 cookies. Okay, so slightly different than what we've done above. Questions on that so far? Yeah, Alex.
When I run that, I get an error that occurred outside of the examples. Have we not gotten there yet?
Oh, I don't know. Let me run it and see if I'm also getting that error. Is it this error, undefined method add cookie?
It says cannot load such file, lib student.
Oh, I will stop sharing and have you share your screen.
I'm gonna bet I renamed something wrong. Hang on.
That's okay. The most like learning I think happens when things go wrong. So I am not displeased. Okay. Live student. Oh yeah, if you name it student underscore class, yeah, you'll need to do that.
Let's see. Now I've got the same error.
Yeah. Yep. Cool. Yeah. So you want to require in exactly what you name that class. I will say, Alex, the strong convention is not to name it student underscore class, but just student.rb.
All right.
So, and again, I think this is a great example of how not following the convention didn't mean that everything broke, right? Like you could still run your tests. It just is. It's the type of thing that if another Rubyist looked at the code, they'd be like, huh, that's interesting that you did that way. Yeah. So yeah, exactly. Awesome. All right, cool. Thank you for sharing your screen. I will go ahead and share my screen again. And okay, yeah, we ran the test. So I see that I've got an undefined method add cookie. So I'm going to go ahead and create that method. So I need to add a cookie, and that method is going to take an argument. And I'm just going to call this argument cookie for now. And what I need to do, so if I run this right now, it's going to tell me like I expected this array of peanut butter and monster, and I got an empty array. And that's because this add cookie method is not doing anything. It's not sending this cookie into my cookies array yet. So I need to actually tell my method to make the change that I want to see in the world, which is to add my cookie, shovel that cookie into my cookies array. So if I run this, now this all passes. All right, cool. Oh yeah, there's one other thing that I want to talk about. So earlier, Catherine had asked about like, sometimes you'll see tests where you have a describe and then a describe and then an it. So the way that I've done this here with one describe and just a bunch of its, this works, right? We're running our tests, it's working. RSpec is a really handy tool because it allows you to be really specific and descriptive about your tests in a way that other frameworks don't allow for. And what I mean by that is right now we just have a list of tests. There's no like division of this is what happens when we create an object. And then here are some methods that you can call on that object. And so what you'll often see is folks do something like this, where I might say like describe like instantiation, or maybe like describe initialize. And then I might, let's see, do, and I might nest all of the things that are related to the creation of that object inside of this describe block. And this is purely organizational. It's purely for our human eyes to sort of see like different chunks of functionality. So when I am writing these tests, I will often do just this, where I usually don't call it initialize. I usually describe like object creation. And then I might have another describe block, describe instance methods. And I'll put like my non-creation related instance methods in here, or methods in here. And this is purely for our human brains to sort of be able to see different related chunks of code. There's nothing that changes in terms of the functionality of these tests running. So if I run these again, we still see 4 examples, 0 errors. This is just to help human eyes read through all these tests. And you can nest as many describes as you need. I would say you usually see like 2 or 3 max, but you can keep nesting them as much as you want. And then your it blocks, these tests, are like where the magic happens. The describes are sort of just like, here's some text for you humans to understand what is going on here. Okay, so you'll see lots of different ways. Yeah, Marla.
Is there a way to like make a test only check a certain describe block? Like, is that a thing, or is it's purely just to look at? It doesn't actually offer any additional functionality?
So yeah, there is a way to make a test run just a specific describe block, and I can't remember the command off the top of my head. But if you Google RSpec run only one describe, you might find it.
Okay, cool.
Yeah. Michael.
When you run RSpec, and I guess if you hide some of the its, or if you temporarily skip them, it'll show that the it title as in there. Is there a way for it to show the describe title?
Yes. So there is a way that you can run the test to see some more like documentation. I'm probably going to get this wrong, but I think if you run like -F-D maybe, nope, -FD. Yeah. So if you run RSpec with the F flag and then a D, it will actually like list out all of that text that you're creating. So I see like my first describe is student, and student object creation, it can be created, has a name, starts with no cookies. And then I see a block for the instance methods. And so like there are ways, and I won't cover it here today, but there are ways to set up your test so that automatically runs with this format. You could Google that. That'd be a cool thing. But yeah, you can do that. Matt.
I have an Adam related question.
Yeah.
I think that the predictive text is a fantastic tool, but using tab or enter is what gets them into your text. But I want to know if there's any way other than adding a space and then taking that space away to not use what it's trying to predict, because I can try to press enter to go to the next line, but it's just going to use what it was predicting.
Yeah, you can turn off auto predict.
Would you advise that?
It's totally personal preference. I have just gotten into the habit of mostly getting around that auto text by like spacing, backspacing, and then entering, and that works for me. Mike is like very against auto complete, so Mike has his not turned on. Totally personal preference.
I just want to chime in. If you do shift and then enter, it will, or like command enter, it'll go down to the next line without auto completing.
That's excellent advice. Thank you.
Thank you, Jacob. All right, cool. There are a couple of other things that I really want to get to, so I'm going to keep moving forward. If you have other questions, let's go ahead and post them in the thread in Slack. But I'm going to share my tablet again. Screen mirroring. Book. Yep. Okay, great. And yes, we're going to go back to this thing that I'm not super great at using, but we're going to stick with it for now. Okay, cool. So a couple of other things around testing as a concept. We've talked a little bit about this, but we adhere to TDD, which is test-driven development at Turing. And that's what I've been modeling for you today. I wrote a test and then wrote the code to make that test pass. And that really helps us keep our code nice and clean. I only wrote the code that I absolutely needed in order to make a test pass. I didn't add any extra attributes to the student. I didn't add any extra functionality. I just built what I need. One question that I get from students often is like, how do I write a test if I don't really know at all what the shape of this project of this problem is going to be? Like, sometimes like TDD is the ideal, right? But sometimes we don't really know what a problem is going to look like or what that problem space really needs to be. And so there's this idea of spiking, which is, I know that I am going to need to write a test for this at some point, but before I even know enough to write a test, I'm just going to like play around with some code. So I'm going to spike and play around with some code until I figure out a little bit more about this problem so that I have the information that I need to write a test. Now with spiking, what you want to do is like play around a little bit, come to a point where you understand enough to write a test, delete that code that you spiked on, write the test, and then implement your code based on that test. Because the likelihood is like while you were spiking, you wrote some like extra things that you probably don't really need. And so instead of like accidentally leaving those things in as you write your test, once you've spiked and you can see the shape of the problem, blow that code away. Code is cheap. You wrote it once, you can write it again, write your test, and then write the code to make that test pass. Cool. All right. Okay, so tests always have 4 components: setup, setup, execution, assertion, and teardown. So all tests have these 4 pieces. So what that looks like is if we have a test, if we have this like name test, the setup piece of it is this line right here where we're creating a student. The setup is everything we need to exist in this little block in order to run the test, in order to confirm a piece of information. What needs to exist in this world? And by in this world, I mean like in this it block. Okay. We also have some execution, and the execution is like running the method that you're testing. So the execution piece is right here. The method I'm testing is the name method, and I'm executing it when I call student.name. The assertion is the confirmation that that method is working as I expect. So the assertion is this whole expect line. So in this example, the execution is happening in the same line as the assertion, but they are 2 different steps in the test process. So we've got our setup, our execution, and our assertion. And then the last piece of testing is teardown. And this is actually something that as not as Rubious, I would say, but like using RSpec, using many other frameworks, the teardown happens automatically. The teardown is basically like, I created some setup and now I want to like get rid of all the setup that I have. The teardown happens automatically for us. So you don't need to really think too much about it other than to know that it is part of the 4 stages of testing. Okay, so if you write a test, you should be able to point to at least the setup, execution, and assertion stage of your test. Let's look at one other example of this. This is the add cookie test. And here it's slightly different. The setup is the same. The execution is actually happening on these 2 lines. We're running this add cookie method. And the assertion is separate from the execution. So when we have this sort of like commanding or changing method, it's really clear in the test that we have 3 different stages: the setup, the execution, the assertion. Okay, and I can't remember who had this question earlier, but this is why I include that space above the assertion. I'm sort of like visually indicating to myself, like, I'm at a new stage of my test. I'm at the like most important part, the assertion. Yeah, Catherine.
So I was working on like a practice I see this morning, and I kind of noticed that like I got stuck on an error, and I noticed that the setup between the iterations can change, like very like minor things. And I was a little taken aback.
Yeah, your setup will not always be the same for every single test. Yeah, your setup could change. And that's why setup is one of the stages of test, because it needs to be, you know, your environment, your little world inside that it block needs to be set up for that specific method test. Michael.
On the first test, you have student.name is the execution. On the second test, would student.cookies be a part of execution along with the 2 you have highlighted?
Not really, because the execution really refers to executing the method that you are testing. And so I'm actually testing the add cookie method. I'm using other methods to help me make that assertion, or that, I'm using other methods to make the assertion that's going to test or confirm that add cookies is working. So the, a key difference, I think, is in this has a name test, I am testing the name method. It just so happens that in this test, I'm combining 2 of the stages. I'm combining execution and assertion. In the test below, I'm testing add cookie, and I'm simply, maybe not simply, that's a bad word. I'm using cookies to confirm that the method that I really care about is working.
Okay. Got it. Thanks.
Cool. All right, sweet. We've hit everything that is like very, very important to know. There's like a lot in testing that we will continue to talk about as we do things like independent challenges, review projects, things like that. But I'm going to leave it here, and I believe y'all are with Mike next. Is Mike still in the call?
Yep.
Oh, hello, Mike. Do you want me just to give you host privileges?
Yeah, give me host. Cool. Can you all hear that siren behind me?
A little bit, yes.
Great.
I'm gonna stop this recording and then give you a host.